Uh, hello. Hello, Professor. My name is Pavani. Today I'm going to talk about my automata final project, which is CKY Parsing. Uh, I'm doing the library book search. Um, First, I would start with the description. So in this project, the context-free grammar, its derivatives, base case lexicons, and other related topics have been covered. So here I have constructed 15 valid sentences and 3 invalid statements, including the staff collaboration book organization. So according to the library book search, I have created 15 valid sentences and 3 invalid sentences. So first I have taken the context-free grammar and I have converted the context-free grammar into the Chomsky normal form. And afterwards, I have parsed the tables, which is CKY tables have been formed. And in this project, I have used the Python code to check the calculations and also to check if the sentence is valid or invalid. And for more practical use of this project, NLP, the natural language processing, which utilizes the chatter board, can be utilized for more practical approach of this. So next, I will talk about the context-free grammar. So in this, the CFG includes. So on the right hand side, it represents the terminal symbols typically, which it is produced by the grammar, and on the left hand side, it represents the non-terminal symbols, which acts as a placeholders for the terminal symbols. And also, if we see S is nothing but the starting point and it's the beginning stage. So we have a set of production rules that can convert the proficient method to convert the terminal and non-terminal symbols are given. So the main goal of this project is the context-free grammar will be converted to the Chomsky normal form. So if we see here, this is the context-free grammar I have taken. So as the starting point, and if we see, we have the right-hand side will be the non-terminal symbols. So if we see, we have three non-terminal symbols, four non-terminal symbols like that. So we'll have to convert this grammar into the Chomsky normal form. When you see in this slide, I have converted the context-free grammar to the Chomsky normal form where I have taken only two non-terminal symbols. So there are certain rules for converting to the Chomsky normal form. One is we'll have to kill if there is any null production. And the second one is we'll have to kill if there are any unit productions. And the right side, it should contain only two non-terminal symbols. Here, if we see, this grammar contains three non-terminal symbols. And if we see here, I have converted that into two non-terminal symbols. And I have also taken few random words for generating my sentences like request, assist. These are the terms or the words that I have taken to create the sentences. And here I have, these are the 15 valid sentences that I have taken um, in this project. And here we can see the three invalid sentences. Like for me, take a book, these are the invalid sentences. Next, I would like to show how I parsed tables like the CKY parsing. So this is a parse table, and this is the calculation that I have done according to it. So if you see in this table, the top left side of this table shows the shows S, which means this represents this particular sentence is a valid sentence. If the top right side of the cell shows the S, it means it is a valid sentence. So when you go to the other sentence that I have taken, it is anyone arrange this bookshelf. Here also it shows S, so it means it's a valid sentence. And next I have taken one more example, that is this library take no ebook. This is also, if we can see, it shows S, which means it's a valid sentence. So in the next sentence I have taken is for me take a book. So here on the top right side, it shows X, which means it is not a valid sentence. It is not showing S, so it is not a valid sentence. And the next one, again, I have taken from anyone request that ebook. This is also doesn't show any S on this table, so it is an invalid sentence. Next, I would like to show the Python implementation. So I would like to show the Python implementation here. Um, so here is the Python. I'll open the Python implementation. Okay, if you see here, first I have imported the NLTK, which is Natural Language Toolkit. So from this library, I am using the functions like tokenization and also the CKY parsing. So that is the reason I had to import this NLTK. So tokenization, what does it does it? It splits the sentence into words, and also the CKY is the context free grammar also comes from this library. So that is the reason I'm importing here. And if you see, I have defined the CKY parts, and here I've given two arguments, words in the grammar. So words is nothing but the number of words in the input sentence, and grammar is a CFG grammar, which is context-free grammar. And this table I have initialized, and it has the word count plus one argument. And there is a for loop that iterates over the loop, and it also checks the right hand side and the left hand side of the which I have explained, like the terminals and the non-terminals. It's checked the both, and it also checks the grammar that is produced. So here, if we see, I have written an if statement, which, as I have explained in the presentation, that it should contain S on the top right side of the table. So if it contains S, it returns an invalid sentence. Otherwise, it returns an invalid sentence. So here I have given the grammar that I have converted in the Chomsky normal form. And if you see here in this sentence, it will ask us to enter an input sentence, or we'll have to type quit to exit. So here the words here I have taken the tokenization function, and the result is the defined CKY parse, which will print the result. Now I will show the implementation. So it's asking me to enter a sentence. See, it's giving us the valid sentence. It's also showing the valid sentence. And the other sentences, I would give it as it's giving a valid sentence. And next, valid sentence. I will show one more, two more valid sentences. Valid sentence. Valid sentence. Show one more. Valid sentence. Now I will show the invalid sentence, which are three. See, it's showing a invalid sentence. invalid sentence. Yeah, all the three invalid sentences are given. So this is my code implementation in Python, which shows the valid and invalid sentences. And thank you.